Okay, so with example 4, we have x to the third plus 8 over x squared minus 4. So this is a sum of cubes, and this is a difference of squares. So we want to use our sum of cubes rule when we factor out the numerator. So remember, we're going to take the cube root of both pieces. So that's going to give us x plus 2. And then we're going to form our trinomial by squaring the first, opposite sign, product of the two, always a plus, square the last. So you factored your numerator. Now we're going to factor the denominator with our difference of squares. So that's x plus 2, x minus 2. Your common factors are going to be x plus 2 divided by x plus 2. So we're left with x squared minus 2x plus 4 over x minus 2 as your simplified form. So now, restrictions, if you looked at everything, when everything's factored, it's when you want to look at the denominator for your restrictions. So we could not have negative 2 or positive 2 for your restrictions. So our domain would be negative infinity to negative 2, then negative 2 to positive 2, and then 2 to infinity. So you have two your term problems. I'm going to do these with you simply because it does require quite a bit of factoring, and I feel like you guys need that review. So our first problem, I'm going to come down here. So here's our numerator, but if you look, I'm going to switch these around and write them in descending order. So I'm going to do negative 2x to the third plus 18x. And then we'll start factoring from there. So I can see that we have a GCF in the numerator of x. So that's going to be 2x squared plus x minus 15 when we factor out the GCF of x. In our denominator, we can factor out a negative 2x, and that's going to leave me with x squared minus 9. So then we want to try to do AC, so I'm just going to make a little note with our numerator. So if you need to go to the side somewhere, I'm going to come back up here where I've got some space so I can do AC. So I need 2 times negative 15 is negative 30, and I need factors of that that's going to add to be positive 1. So that's going to be negative 5, positive 6. So I'll have 2x squared minus 5x plus 6x minus 15. We'll group that together. So our GCF in the first group is x. That'll leave us with 2x minus 5. Sign in the middle always comes down. We can factor out a 3, and that'll leave us with 2x minus 5. So there's that twin I was talking about. So you use what's on the outside of parentheses, x plus 3, and then write your twin. So we have x times x plus 3 times 2x minus 5 in our numerator. This x squared minus 9 is a difference of squares. So we have negative 2x times x plus 3, x minus 3. So we're going to look for common factors. So this x and this x will go away. Actually, before I do that, guys, let's go ahead and do our restrictions. So when we're doing restrictions, we're actually saying, okay, this factor cannot equal 0. So if I said negative 2x cannot equal 0, because I know if that equals 0, the whole denominator equals 0. If I solve that, I would get x cannot equal 0. Same thing with the 3. If we said, okay, the x plus 3 cannot equal 0, when we subtract, you would get could not equal negative 3. And then with the x minus 3, we would get x could not equal positive 3. So that's how I'm coming up with those restrictions. So I'm going to come over here and just write those. So x cannot equal, and I'm going to put them in order to help me. So negative 3, 0, and 3. This will help me when I start to write the domain. So you actually have 3 restrictions this time. Now let's go back to crossing out our common factors. So those 2 x's would go away. This x plus 3 and this x plus 3 we could cancel out. So then in our numerator we have 2x minus 5, and then in the denominator we have negative 2 times x minus 3. And we can just stop with it there because there's nothing else we can cancel out. So now let's think about writing that domain. So I'm going to do a number line again just to help you think through this. So negative infinity to positive infinity, negative 3, 0, and 3. So again, we can't use either of these numbers. So when I write my domain, I'm going to start at negative infinity, come up to negative 3, can't use negative 3. Now I need from negative 3 to 0. Now I need from 0 to 3. And then we need 3 to infinity. So there's the domain for that function. Okay, so number 2, we have 2x to the third plus 16x squared plus 24x over x to the fourth minus 40x squared plus 144. So I have a GCF in the numerator. So I'm going to bring that out. 2x, that's going to leave me x squared plus 8x plus 12. Okay, and the denominator, so we can do AC with this. I know this is not the standard form that you're used to, but if you have x to the fourth, x squared, and 144, I can go ahead and do AC here. So I need factors of 144 that are going to give me negative 40, and that's going to be negative 4, negative 36. So we're going to have x to the fourth minus 4x squared minus 36x squared plus 144. I'm going to group those up. So here GCF is going to be x squared. That's going to leave me x squared minus 4. Here our GCF is going to be 36. That's going to leave me x squared minus 4. So we have x squared minus 36 and then x squared minus 4. But then guys, this is a difference of squares. So that's x plus 6, x minus 6. That's a difference of squares. So that's x plus 2, x minus 2. Oh, so we had a lot of factoring going on there. So we have x plus 6, x minus 6, x plus 2, x minus 2. And then we're not quite finished because I still can do AC with this numerator. So I have 2x times, so then think about this. Factors of 12 that will give you 8 would be 2 and 6. So x plus 2, x plus 6. We get to do the shortcut on that one. So I'm going to bring all this over again. And now we're going to cross out common factors. So then that's going to leave me 2x over x minus 6, x minus 2 for our simplified form. Okay, so here I'm going to look at my restrictions. So x could not be negative 6, x could not be positive 6, x could not be negative 2 or positive 2. So there's my restrictions. So again, to give you that visual, I'm going to put these in order. So -6, -2, +2, +6. So think about, I can use every number except those we're crossing out. So for your domain, we're going to have -infinity to -6, -6 to -2, -2 to 2, 2 to 6, and 6 to infinity. So there's the domain for that function.